need to expose Python functions directly to Claude Code or Cursor with minimal boilerplate. You'll see how the @MCP tool decorator instantly converts a standard dice rolling function into an AI-callable endpoint, complete with automatic schema generation from type hints, while supporting multiple transport methods including HTTP, STDIO, and SSC. The server name you provide appears directly in the AI interface and will demonstrate both local testing and remote deployment patterns. From FastMCP, import FastMCP. Import random. MCP equals FastMCP, demo server. @MCP, tool. Def roll dice sides, int equals 6 int. Roll a dice with the specified number of sides. Return random, randint 1 sides. If name equals main. MCP, run transport equals HTTP, port equals 8000. This demonstrates the Claude Cursor tool integration pattern, where Python functions become directly callable by Claude Code and Cursor through a standardized transport layer. The @MCP tool decorator actively exposes functions as API endpoints while maintaining their core logic, creating a bridge between native Python and AI assistant interfaces. The distinctive aspect is how it combines Python's type hints and docstrings with automatic schema generation to create self-documenting tools. The pattern works through declarative exposure rather than imperative API construction. Decorators mark functions for external access, while the framework handles transport methods, STDIO, HTTP, or SSC, parameter validation, and schema generation automatically. This separation means your business logic remains pure Python, while the system manages all integration requirements for Claude and Cursor environments. This approach eliminates most boilerplate associated with building AI-integrated tools, though some server configuration remains necessary. It's particularly valuable when creating plugins for Claude Code or Cursor, where you need to expose backend logic without writing custom transport code. The trade-off is framework dependency, but the productivity gain for AI assistant integration typically justifies this, especially when deploying the same tools across local, STDIO, and remote, HTTP SSC environments. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for exposing Python functions to Claude Code and Cursor as callable tools. It handles transport methods including STDIO, SSC, and HTTP, while automatically generating schemas from type hints and docstrings. The server name appears in the AI interface, with deployment options for both local and remote execution. Import random. Imports Python's built-in random module to enable pseudorandom number generation. This provides the randint function used in the roll dice tool, ensuring the dice roll produces unpredictable results between 1 and the specified number of sides. The module is part of Python's standard library, requiring no additional installation. MCP equals FastMCP, demo server. This creates the FastMCP server instance named demo server that will appear in Claude Code and Cursor interfaces. The instance serves as the central registry for all AI-exposed tools, handling serialization, transport, and execution across STDIO, SSC, and HTTP protocols. @MCP, tool. Def roll dice sides, int equals 6 int. Roll a dice with the specified number of sides. The @MCP tool decorator exposes this function to Claude Code and Cursor as an AI-callable endpoint. FastMCP automatically generates the tool schema from the type hints and docstring, handling all serialization and transport configuration. This follows the standard FastMCP tool pattern. Python functions become invocable with zero boilerplate, working across all transport methods including STDIO, SSE, and HTTP.
Return random, randant one sides.
Generates a random integer between 1 and the specified sides parameter using Python's random, randant, simulating a physical dice roll. This becomes the tool's output value that FastMCP serializes and returns to the calling AI system like Claude Code or Cursor. The range validation is handled automatically by randant, ensuring results stay within the 1 to sides boundary.
If name equals main.
Python's standard module guard prevents the server from launching when this file is imported, ensuring MCP, run, only executes during direct script execution, required for proper FastMCP deployment.
MCP, run transport equals HTTP, port equals 8000.
Starts the FastMCP server on port 8000 using HTTP transport, exposing all at MCP tool-decorated functions as callable endpoints for Claude Code and Cursor. The server handles automatic serialization, validation, and routing while maintaining the original Python function behavior for local calls. This single line enables both local STDIO and remote HTTP SSE deployments with identical tool definitions. FastMCP Claude Cursor integration. The at MCP tool decorator exposes Python functions as callable endpoints for Claude Code and Cursor, automatically generating schemas from type hints and docstrings. Transport methods like HTTP, SSE, and STDIO determine how these tools connect, with the same decorator pattern working across all deployment types. The server name you provide appears directly in the AI interface, so choose descriptive names for clarity.
The function that gains an endpoint loses its local boundaries.